And so finally for 1C, so for the freezing point depression and boiling point elevation, let's do the, well, first thing that I've got to do is actually calculate the molality of the solution. So I've got to calculate molality of NaCl, which is going to be the number of moles of NaCl divided by the kilograms of solution. And let's see here. I didn't give you the density of this solution. So I'm going to write here, assume, and I'll make sure that I have this note in the exam, assume that the density of the sodium chloride solution, I'm going to write 1.02 grams per milliliter, okay? So I would have to give that to you in the future, okay? So now let's see. We know that we did, so to get this molality, all right, or to get the mass of the solution, it's going to be, once again, the 2 times 236.59. Let's see here. Oh, you know what we can do? All we need is the mass of both quantities. Aha, I just got tricked in my own problem. So if I just need the mass of the solution, the mass of the solution is just going to be the mass of the sodium chloride plus the mass of water, right? Okay, so I was overthinking that. So kilogram of solution. So for the mass of sodium chloride, so we know it was 2.19 mole. So 2.19 mole of NaCl, I'm just going to work backwards. In 1 mole, it's 58.46 grams. And then I know for water, it's 26.27 mole of H2O. And I know 1 mole of H2O is 18.01 grams. Okay. So let's see here. So 2.19 times 58.46 equals, so that's 128, we'll leave it there, that's fine, 128 grams there. All right, and then 26.27 times 18.01, and that's 473. We'll just leave it at that number, sig figs, grams, okay? So that's the mass of my solute and the mass of the solvent. The mass of the solution is the mass of the solute plus the mass of the solvent, okay? So that plus that, so plus 128 equals, so the mass of my solution is 601 grams, and there's 1,000 grams in 1 kilogram to give me 0.601 kilograms. So my NaCl molality is going to be here 2.19 moles of NaCl divided by 0.601 kilograms of solution. So let's say flip that number times 2.19 equals, and I get my molality to be 0.00364 molal. So hopefully I have left myself just barely enough room here to do this delta T. So let's first do the boiling point. So that's going to be the Van 't Hoff factor. So let's back up and look at the equation, right? It's the Van 't Hoff factor times the molal boiling point constant times the molality. So once you get the molality, that's the hard part. It's not so bad. So now delta T is going to be 2 times, and then this number is 0.51 degrees C kilogram per mole times 0.00364 mole per kilogram. Okay, so let's see what I get there. So 2 times 0.00364, I suppose I could have left that number in the calculator, times 0.51 equals, and so not a whole, oh, you know what I think I did wrong here? Oh my gosh. I calculated this molality wrong because there should have been a much bigger difference in the boiling point, and I think I know what I did. I think I divided it by 601 instead of 0.601. So let's try that again. 2.19 divided by 0.601 equals, that's a big difference, 3.64 mole per kilogram. So now this is 3.64 mole per kilogram. Okay. Yeah, there should be a very significant change in the boiling point when you add salt. So then times that number and then times 2. And so I get my delta T as 3.72 degrees C. Okay, so that's my change in boiling point. Well, remember the boiling point of water is 100 degrees. So that means my new boiling point, because it's boiling point elevation, my new boiling point is going to be 103.72 degrees. Okay, what about my new freezing point? Well, that's see, delta TB. So then delta TF is also going to be 2, Van Hoff factor, expected Van Hoff factor is fine, times now the KF constant, 1.86, also times that 3.64. Okay, so let's see here, 3.64 times 1.86 times 2. So that's a really big change in the freezing point. Okay, so that equals the delta T 13.5 degrees C. And here's what we have to remember. It's freezing point depression. So the change in freezing point is 13.5 degrees. We have to recognize the normal freezing point of water is 0 degrees. So the new freezing point is going to be negative 13.5 degrees C. And for those of you that have lived in really wintry climates, you might remember that they put salt on the roads. This is why. It significantly lowers the freezing point of water and prevents the buildup of ice on the roads and the wintertime temperatures, okay? So this is the free response question for the exam, or something very similar. So I know I was kind of scatterbrained when I did it, so just make sure you're following along, okay, folks? So moving on, just a